Greetings and welcome, friends. Mr. Waddy here with my most favorite Algebra 1 class this semester. Don't tell them they're the only Algebra 1 class this semester I have. That's fine, but you're still my favorite right now. Right now. I don't know. Don't worry. I love you guys. So here we go. We're talking about point-slope form, page 185, some homework problems, and I want to find the equation of a linear function f with the given values. Now, in order to do that, we're actually going to work with point-slope form, which is y minus y1 equals m parentheses x minus x1. The wonderful thing about point slope form is that when you have a point in the slope, you can just write the equation very easily. And when you have an equation, you can look at it and quickly discern a point in the slope of the line. So you can kind of already start visualizing what it looks like. So here's point slope form. The other thing that'll help us out here, which notice this problem didn't clue us into this at all, right? It didn't say like, oh, you need point slope form, and also you need slope formula. It didn't tell us that. We just needed to smuggle that in our brain box and know that those were the tools that were going to help us to solve this problem. All right, so those are the two things I need: slope formula and point slope form. Here I've got things that we'll call 2 points. And if I rewrite this, I'll think of this as 2 comma negative 2. Right? This is written in a function notation. So when the input was 2, the output was negative 2. When the input was 1, the output was 1. All right? So I could have thought of these facts as points. All right? You don't have to write them as points. If you just happen to be very familiar with function notation, you'd be fine. But I think it's a good idea to just write them as points and even label them x1, y1, x2 with the y2, and let's find some slope. So m is going to equal y2 minus y1 over x2 minus x1. And so m is going to equal 1 minus a negative 2 is 1 plus 2, which is 3. 1 minus 2 is negative 1. And what do I find for my slope? M is going to equal negative 3. All right. So now I've got the slope and I've got 2 points to work with. So I can now plug that information into point slope form, and I can actually use either point that I want. Which point do you like? Which point seems easier to work with, friends? The point 2, the 1 and the 1, right? That seems to be way easier. Those are smaller numbers. They're both positive. So let's use that. So let's do, we'll use this point for my, I know they're labeled incorrectly according to this, but we'll just, I guess I could call this y2 and x2 now, and that's fine. So let's see, y minus y2 now equals m, all right, which is negative 3, parentheses x minus x2 now in this case, right? And so I plug it in, but they wanted a linear function f. So they're going to want this solved for the output and written in function notation. So right now, this is the equation of a line. Like, if I just said, find the equation of a line through these points, we would be done, right? This is perfectly good. You also could have used this, and you would have had a different looking equation, but it is representing the same line. So if I want to convert this to y equals mx plus b, I would distribute first. I'd have the y minus 1 equals negative 3x plus 3 when I distribute using multiplication. And to solve for the y, I will add 1 to both sides to get the y by itself. We're getting good at this, I hope, right? Yeah? So y equals negative 3x plus 4. So here's slope-intercept form. You could now tell me, oh, it's got a slope of negative 3. We already knew that. And a y-intercept of 4, which I didn't know. Right? I didn't know, because if one of these points was already the y-intercept, it would have had to have had 0 as an x-coordinate. So I didn't know the y-intercept before this. But they wanted it in function notation in terms of f. So we'll rename this f of x equals negative 3x plus 4. All right? And so using the clues I was given, I was able to find the slope, write point slope form, convert it to y equals mx plus b, slope-intercept form, and then write it in function notation. Yes. All right. Same type of problem. Let's jump into one with a table here. Question 27. All right, so here's a table. I could view any of these as being like my my points, okay? I could just pick any of those. I could have thought of this as x1, y1. I could have thought of this as x2, y2. All right, I can work with any of those once it's linear, once I know it's linear. But first it asks, tell whether or not the data can be modeled by a linear equation. I don't know if it's linear yet, because not all relationships between points have a linear outcome. They don't always have a constant rate of change. Sometimes a graph might be like speeding up, or sometimes a graph might be going woo, 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 right? And that's like non-linear situations here. So if I want to figure that out, I've got to compare the rates of change. So to go from -1 to 5, I was adding 6. To go to 2 to 4, I was adding 2. All right, so up 6 over 2 would be the slope between those 2 points. Let's see if that pattern continues. 5 to 15, that's, well, plus 10. Uh-oh. And, 4 to 6 is plus 2. So, guys, it just got steeper. This is not linear. 15 to 29, that's plus 14. Uh-oh. And this is plus 2. It just got steeper again. Oh, my goodness. And 29 to 47, that looks like plus 16. Guys, this is not linear. This is not linear. All hands on deck. Not linear, because it has it doesn't have a constant rate of change. So this is not a linear function. Ooh. Ooh. Not a linear function. It doesn't have a constant rate of change. Doesn't have a constant rate of change. So I guess good news for us, we don't have to do this problem. It just like disqualified itself from being a slope-intercept form, point-slope form problem. So yeah, so no, I'm not gonna. You can't make me write a linear equation that represents this. But if I found out it was linear, what I would have done was found the slope between 2 points. I would have plugged in one of the points as x1, y1, written point-slope form, and then converted it to y equals mx plus b. If they actually, they wouldn't even need it. I technically could have left it in point-slope form. Let's see, here's question 31. Oh, I love these problems, right? You guys like these problems, I'm sure. Describe and correct the error in writing a linear function g with values g of 5 equals 4 and g of 3 equals 10. Well, let's see. Let's g of 5 equals 4, that's the point 5, comma 4. G of 3 equals 10, that's the same as the point 3, comma 10. So if I label these x1 and y1 and x2 and y2, it looks like they used the slope formula. Did they do it correctly? y2 minus y1, 10 minus 4, over x2 minus x1, so 3 minus 5. Good so far. Let's see. 10 minus 4 is 6. All right. 3 minus 5 is -2, and 6 divided by -2, 6 divided by 2 is 3, and it keeps the minus sign. Okay, so far, I agree. Oh, does anyone see their problem yet? They plugged this into point-slope form, but wait a minute. Yeah, point-slope form needs parentheses here. Oh, no. Error, my friends. So, yeah, they didn't plug it into the correct form. So let's do that for them, shall we? So y minus 4 equals -3 parentheses x minus 5. Yeah, they just forgot their parentheses by the looks of it. Let me actually just verify. Yeah, y minus 4, yeah, y1, and then x minus 5. Yeah, good. So if I want to fix their problem, I can now distributing, and like so. So y minus 4 equals -3x plus 15. And then, yeah, let's, yeah, we'll write it as a function g. Okay, yeah, so I do have to, yeah, put this in slope-intercept form first to solve for the output variable. So y equals -3x plus 19. And so I could call that g of x equals -3x plus 19. So yeah, so their error was they used the wrong formula. That was like a non-existent, like this doesn't represent anything. That's a non-form. It is linear, but it is not going to represent the line that they were shooting for. So guys, let's take a look at one of these word problems, question 33. Let's see, this year's Algebra 1 students, I didn't make them do this problem, but who knows, maybe my future internet friends, maybe I assign this problem in the future, and maybe you're stuck on it. I'm here to help. But either way, let's all learn from this. I'm gonna have a sip of coffee. So, you are designing a sticker to advertise your band. How did they know my life? I don't understand are they spying on me, guys? How did they know I was doing this weekend? What? This is so crazy. Me and my band, oh, we're so great. I don't have a band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Wow. Okay. Huh. All right. Write an equation that represents the total cost in dollars as a function of number in thousands of stickers ordered. So notice this. So F of, and then what comes next is X. So my X is the number in thousands of stickers ordered. All right. And Y is the total cost in dollars. Right? Total cost. Measured in American dollars. All right. So that's my X and Y. And now up here they gave us two facts. I don't know if you realized that. I don't know a starting value, and I kind of know the slope, I think. All right, I kind of know the slope. So let's see, the first fact they said a company charges $225 for the first 1,000. So what does that fact correspond to? All right, that's the same as saying for the first 1,000 stickers, which wait, X is measured in thousands of stickers, so 1,000 stickers is the same as 1 for my function X, right, for the variable X. Do you guys agree? Do you see why I'm not writing 1,000 there? I'm writing 1 because I'm measuring in thousands, okay? And they're charging $225. So here's like a point that my line passes through. None of those numbers, neither of those numbers represent the slope. And then they gave me a fact. They said they charge $80 for each additional 1,000 stickers. Each, that's like per, right? That's a rate. All right, that sounds like they're giving me slope. And so my slope here is $80 per 1,000. But my X's, my runs, are measured in thousands. So that instead of writing 80 over 1,000, that's the same as 80 over 1. Okay? You guys agree? You see how I got that? So I could write that as 80 over 1, or just M equals 80. Yeah? Yeah, maybe. So let's label our point. I'll call this X1 and Y1. I already know the slope. Wait, point, slope, point, slope, point, slope form? I think so, friends. So I'm going to have Y minus Y1 equals M parentheses X minus X1. Oh, no, you didn't. You already got a solution for us? Well, I was just writing the formula to remind people. You're right. So this is, you could have skipped that step completely. So I'll have Y minus 225 equals 80. Oh, this M up here? Yep. Yeah, absolutely. Absolutely you could. Yep. That's what I end up doing. X minus 1. So here's an equation that represents this situation perfectly. And notice that the starting info I had was a fact, like one particular number in cost for 1,000 stickers. I wrote that as a point, and then I also knew a rate after that. So that was my slope. So here's my equation. Let's see, write an equation that represents, technically I'm done. I could put this in slope-intercept form if you want. Let's do that. Let's do it. Why not, shall we? Let's see, Y minus 225 equals 80x minus 80. And let's add some 225 to both sides. Yes, yes, yes. And I get y equals 80x. Oh man, those signs are different, so I've got to subtract them. 225 minus 80. Let's see, 225 minus 100 would have been 125, and I was 20 off, so 145 plus 145. Now this equation technically only works after the first 1,000 stickers. All right, this I'm guessing. Well, actually, maybe I'm wrong. Maybe I'm wrong. It's the way it's worded though. It sounds like it's like $225, and then they start charging different. So I don't know. Maybe it is linear the whole time. That's fine. So here's my equation. Now they ask the question: find the total cost of 9,000 stickers. Does this represent X or Y in my equation? Here's my variable names. Does that represent X or Y? What are your thoughts? Where would I plug 9,000 in this equation? Ooh. Well, 9,000 is measured in stickers, so that's why I'd have to plug it in for the X. We're going to solve for Y, which will give us the total cost. But yeah, all right. Too bad it wasn't one more sticker, because then I could have said over 9,000 and make a Dragon Ball Z reference, but I won't. I won't. So let's see. So let's plug this in. So that means I'm going to find out for a particular X equals 9,000, what is Y equal to, is what I'm doing. So if I used function notation, if I did call this like f of x equals 8x plus 145, all right, you could have represented this multiple ways. I would have been asking the question, what is f of 9,000 equal to? Right. That's two different ways of asking the same thing. But basically, at the end of the day, I'm plugging in, oh, dear. Nope. Guys, I almost made a big mistake. X is not equal to 9,000. This is measured in thousands. So my X is going to be what number? Austin? That's the same mistake that I was just making right now. It's because the X is measured in, oh, dear me. Guys, did I make multiple mistakes here? $80 for each 1,000. Yes. You got me. All right. You got my back. I appreciate it. Man, I'm making mistakes all over the place. Good thing you guys are paying attention here. All right. So yes, it was $80 per 1,000. I already accounted for that, so this is still 80. Thank you for the save. Whew, man, thank you, Austin. And X is equal to 9 because X is measured in thousands. All right. Whew. Man, multiple errors going on here. So yeah, I'm trying to figure out what is the function equal to when X is 9. So to do that, I'll just use the Y equals version. Y equals 80 times 9 plus 145. Let's see, 80 times 9, what's that? 720, I think, right? Am I doing that right? Because 8 times 9 is 72. Yeah. And add those together, I will get 865. So what does that mean? That 9,000 stickers cost $865. Right? So I can then use my model to predict previously unknown information. Right? That's the value of mathematical modeling. And our models right now are all linear, but later on throughout your high school career, you will discover that you can have models that are curves and quadratics. You could have models that are like sine waves, and you could have exponential growth or decay. And once I have a model that represents some real-world situation, then I can make predictions about situations I previously didn't know. All right, thanks for watching, Internet friends. Have a great day.